For this example, we have an angle of elevation problem, and the difference on this is that we have two different situations because we are moving closer to the object here. So the angle of elevation to the top of a tree sighted from ground level is 15 degrees. So that gives us a situation where we create this right triangle. Angle of elevation is always on the ground. So it's not elevated up, it's actually the angle on the ground looking up towards the top of the object. So this angle of elevation here is 15 degrees, and this represents my tree here. So if the observer moves 60 feet closer, so now the observer is at this point, and then as they move 60 feet closer, so I know that this distance here is 60 feet, then the angle of elevation actually changes, but you're still going up to the same height, and now they're saying the angle of elevation at that point is 40 degrees. Now we want to find the height of the tree. So I can call that x if I want to, or some other variable there. So the first thing I can do is begin with the fact that I've got 60 feet here from where they moved from the 15 degree to the 40 degree. And so I need another variable here to represent the distance from 40 to the tree. So that means this entire distance here is y plus 60 feet. Okay? So let's focus on the triangle that's created here with that 15 degrees. So I'm just focusing on this outer triangle and trying to identify the trig ratio that would go with this. So with this triangle, I have, from the perspective of my 15 degrees, I have the opposite side is x, and I have the adjacent, now the entire adjacent side is the y plus 60 feet. So let's set up that trig ratio. Now the one that we want to use for opposite adjacent is tangent. So tangent of my angle, 15 degrees, is opposite over adjacent, or x over y plus 60. So then I can try to simplify this and maybe solve. I'm ultimately trying to solve for the height of the tree, which is x. So what I can do is I can multiply by y plus 60, not degrees there, on both sides. So I have y plus 60 times tangent of 15 degrees is equal to x, and that's all I can kind of do right now, so let's hold off on that. Now let's use the information where we have this 40 degree angle, okay? So coming from the perspective of the 40 degree angle, I still have the opposite side is still x, and its adjacent side is y. That's still tangent. So for that triangle, I do tangent of the 40 degree angle is equal to the opposite side x over the adjacent side y. Again, I'm going to solve for the variable x here. X is the height of the tree. So to get x alone, I'm going to do the opposite of divide by y, and I'm going to multiply by y on both sides. So y times tangent of 40 degrees is equal to x. Okay, and now if we compare these two equations, the only thing that's really similar about them is the fact that I have two different equations that show me what x equals. So x is equal to y plus 60 times tangent of 15, and x is also equal to y times tangent of 40. So since both of these are equal to x, then I can set them equal to each other. So let's go ahead and do that. I have y plus 60 tangent of 15 degrees equals the other equation, y times tangent of 40 degrees. Let's go ahead and clear the parentheses on the left where I have the multiplication. Let's multiply y times tangent of 15 and 60 times tangent of 15, so distribute there. So I have y times tangent of 15 degrees plus 60 times tangent of 15 degrees. is equal to y times tangent of 40 degrees. And at this point you have one variable y in the equation, so let's get our letters together on the left and let's move this 60 tangent 15 to the right since it doesn't have a variable. So I have y tangent of 15 degrees, just bring that down, and you're going to subtract this y tangent 40 over here because it was positive. And in the same step we're going to subtract, so get negative 60 tangent of 15 degrees here. Our goal here is to try to solve for our letter y. Okay, so because I have two letter y's here, what I'm going to need to do is I'm going to need to factor the y out because it's not like terms, I can't really subtract. So since both of these tangents have a y, we can take the y out and factor it out. And that gives me tangent of 15 degrees minus tangent of 40 degrees equals negative 60 tangent of 15 degrees. And now to solve for y, you just need to divide that group to the other side. So at that point, we have y equals, y equals negative 60 tangent of 15 degrees divided by the group tangent of 15 degrees minus tangent of 40 degrees. Okay. Okay, so that is something that I can type in the calculator at this point because it's all something that is on the right hand side. It all has tangents, and so this is something I can evaluate. And remember, your whole goal is to find the height of the tree, which is x, and you have two equations where it would work. I've got this top equation here and I got this bottom equation here, and comparing both of them, the easier one is the second one. So in order to find my x, I'm going to need to find the y first. So I need to know what's y going to be approximately. And then I can plug in there and then I know my x. So let's get our calculators and we're going to type in y. Well, to find y, we're going to type this in. So make sure your calculator is set to degree mode and not radians or some other mode like that because you will not get the same answer. And I'm going to type in negative 60 tangent of 15, and then I'm going to press equals. And I'm going to leave that number on my calculator. So negative 60 tangent 15 equals, and I have negative 16.07695 on my screen. So let's see if you match that, negative 16.07 approximately. So next, we want to continue with the fraction. Okay, so leave that number on your screen and you're going to divide. Okay, so now I'm going to divide the negative 60 tangent of 15 by that group. Now, you need to use your parentheses on the calculator, okay? So I have this number on my screen, I leave it there, and I do divided by parentheses tangent 15 minus tangent 40, and close your parentheses and press equals. So divided by parentheses, and inside tangent 15. Now my calculator comes up with parentheses around the tangent 15, so if yours does that, you've got to close that off. Minus tangent of 40. So I'd have to double close that. Okay, and I press equals there. Okay, so this result here is giving me approximately 28.14837. So you want to go out to several decimal places there. Now remember, this was what y is right there. Okay, so if I know that that's my y, I can go back and I can really plug it into either x equation, but this one's easier. So x is equal to y times tangent of 40. So x is equal to 28.14837 tangent of 40. So let's just enter that in as you see it, or you can leave the number in your calculator without rounding it. But if you round it, you want to go out to about 4 or 5 decimal places. So enter that in your calculator, multiply by tangent of 40, press equals, and so I'm getting approximately for the x, and sorry, my screen here is just not working well, 23.619. So if they wanted me to round that to the nearest tenth, it would be 23.6 feet, and that would be the height of the tree.